Hey, what's going on, guys? It's Caucasian Mark here, whitest dude on the internet. Let me turn off my really crappy Microsoft external mouse here because it doesn't work that well. Today's video, we're going to be talking about something really cool. We're talking about logical operators. Now, I'm going to be using Boolean values for this. Don't freak out. It's pretty cool and it makes sense. So, if you don't like math, you may or may not like this. I like logic, so let's get moving here. So, what are we going to start off with? Well, one of our first Boolean operators, let's make a comment up here, is going to be AND. Another one will be OR. Another one is exclusive OR. The last one is NOT. If you like the movie Borat, you will especially like NOT. I will spare you my impersonation of that character from the movie, so let's keep this thing rolling. First off here, we have an if-else statement here. So we know from before, we say if this may or may not be true, do this. We have the else here, so in case our if tests wrongly, false, whatever, we have another kind of result that could come out from there telling us what the matter at hand may be. So let's first put this in. We have first value. I wrote two Booleans up here. I did this one and then this one down here. First value is true. Second value is true. I will change these in a moment, but let's just keep this running for now. As we see here, our first value, if we run it, it's going to be true, right? Because I set the value up here, Boolean first value, to be true. And this statement says, if this is true, print out the word true. Awesome. We're on track. Cool. But let's start with not, since it is kind of my favorite, and it is, I want to say the most popular one, at least from my studies and what I've seen. If we put the exclamation point in front of it, we are saying we are flipping the value. We are changing it from true to false. We could do it up here, right? But say we don't want to directly affect the initial value we set first value to be. We just want to do it in this statement. So if we flip it here, we can see that it's false because we negated the validity of the first value to be false. Cool. So what if we did this here then? We're going to put in second value down below, which is false. Now we're going to flip that. Yay, we can see that it's true. How bitchin' is that? You are now officially the coolest person in the world besides me, because I'm drinking coffee out of a mug that looks like a cow's udder, and it is really weird. So, let's go to this next one up here. Let's do, since we have a true and false value now, let's do first value. I can't see because the cursor's in the way there. Do the second one, second value. And when we say first and second, what we're trying to get at here is we want to say if the first value and second value comes out to be true. So what do you think we're going to get? First value is true, second value is false. It should print out what's in the else statement part here, and it should say false. And correct, it says false. How cool is that? Now we could also do this, and it still runs as false. That is because there are two kinds of AND logical operators you can think of. So if we come back here, the double one we can see is the short-circuiting one. This means that everything on the left that you see, it'll check for its validity first. So since first value is true, this is cool, it passed the test, and it looks at the other value, which is second value, which is false. Then the compiler makes a decision saying, sorry, this isn't a logical statement. If we flip these around and had second value, let's just go ahead and do it. And first value here, the build time is still the same, but you still get the same result. Yet it only checks the second value and says, hey, this is an AND statement, and one of these things is false, I'm not going to look at the rest of it. Now, right now in this kind of program, you may be like, oh, well, whatever, cool. I don't care. I could just flip them around, whatnot. But it may save you time later on in the future. I know computers getting faster, all the other shit out there, but just to let you know that you can use either a single or a double right here. I like using the short circuiting just because it's what I'm used to typing. But what if you come into another situation where you want an or? We could have a situation where we go to the store and we want either this or that. Either one we'll be happy with, as long as we have at least one we want. Well, we could denote that by having or. It's basically the two vertical lines in there, and this says, as long as one of these values is true, or at least something is true in here, it's going to come out true. If everything in an or statement is false, well then, well shit, we're out of luck, and it's going to be false. So let's go ahead and run this, remembering that first value is true, second value is false, and it's going to be true. Awesome. Thumbs up. Give yourself a pat on the back, crack a beer, whatever you want. But let's come back down in here and let's make first value up here false. Actually, you know what? Let's keep first value true and let's negate it there. And it's going to come out as false. Why? Because everything is false. Because in an or statement, like I just said, everything has to be true. Cool stuff. Awesome. And you could also still have the single line in there, which is the non-short circuiting way of doing the or statement. But I always just find it's easier for my memory to either just double up on the and the or, just having two of the same symbol back to back, because it does make it a little bit faster behind the scenes. So what do we have left? We have the exclusive or. Now this one is kind of funky here. Now this is kind of saying like this or that. As long as you have a value of both, I'm very happy about it. So we should expect to have true, which we do. But what if we have two true values? Let's just say second value again, which is kind of saying if this is false and this is false, what's going to happen? It's going to be false. But if we flip it over to first value, it's going to be true because we have one of every truth value. We have something that's true, we have something that's false. So what if we wanted to make everything true? Let's just do what we did with the second value there. And that's still going to come back as false. And like I just said, we want one of every value, which is only two of them, represented in that logical statement. So that is a very simple intro to using the logical operators. You can use them in varying scenarios when you're asking questions about the truth statement of a situation, and there's different ways to represent the data coming in there. But this is the basic go over for all you new people or people reviewing, coming back into it or whatnot. I'm Caucasian Mark. Like, share, subscribe, contribute. Give me a speech therapist because I'm stuttering. But I also have been up since 5 this morning, so give me a break. Peace out.